are going to do a little bit of review, and so we're going to focus today's review on working with expressions, and so let's get started. In Algebra 1, we had to do a handful of different types of expression work, and one of them was to take an expression that contained exponents and simplify it. And so the process I said for you to do, to take some beast like this and try to clean it up, was to focus on if there were any groups. First, rewrite it without any groups. And to do that, you were effectively thinking about using the distributive property. Then I suggested you rewrite it without any negative exponents. Notice this has some negative exponents. It also has negative signs. They're different. So the negative exponents indicate that something is a reciprocal, and so something ought to be flipped. Something is divided instead of multiplied. Once you've rewritten it without groups and negative exponents, then you determine whether your answer is positive or negative. And that's simply by thinking about how many negative signs there are using the odd-even rule. Then you would multiply all the number factors together, otherwise called coefficients, and finally determine what the variable part of your answer is by collecting all the variables together and writing that with exponents. I like to summarize those as the three things you always do in a multiplication problem. Is it positive or negative? What's the number part? What's the variable part? And at some point in that process, you have to think about reducing the fractions, whatever coefficients you have. I usually do that when I do step 4. So anyway, here is an expression. Let's see if we can tackle it a moment. So first thing I would do is rewrite it without any groups. So I've got this 4 as an exponent here. I'm going to distribute that to the 2. So it'll become 2 to the 4th, and 3 times 4 is 12, so u to the 12th. This negative 3 goes to the 4th, and w to the 4th. There are 4 of them in each group, and 4 groups. That would be 16. Continuing the rest of that, we end up with this expression after everything has been distributed. And so the next step would be to rewrite it without any negative exponents. And so in this expression, there's only one negative exponent. That's this u to the negative 8. I would suggest that you flip that you move the u to the 8 into the denominator and write it as u to the 8th then. And so that would give us this expression. Feel free, by the way, at any time to pause this and digest these. I'm moving quick on purpose because we've got a lot of ground to cover, and it is review after all. But if you need to look carefully at any point, you may totally pause it. At this point, now we have to answer the 3 questions. Is it positive or negative? What's the number part? What's the variable part? So I'm going to excuse myself for a little bit just so you can have some room to see. And so when I'm looking at this, if I'm thinking about positive or negative, there are a few negative signs in this problem. There happens to be 4 negative signs in this problem. And so 4 negative signs is an even number of them, and that means my answer is going to end up being positive. You don't technically have to write the plus sign, but I'm writing it down just to show you that I've thought about it. The next thing I will think about is all the numbers. So there's 2 to the 4th, there's 3 to the 4th on the bottom, and there's 4 squared on the bottom. And so if we gather all those numbers together, we've got 2 times 2 times 2 times 2 on top, 3 times 3 times 3 times 3 times 4 times 4 on the bottom. And you could get out a calculator and do all that calculating if you want. Some of this can be cleaned up ahead of time, though. If you notice, there's a 2 on top and a 4 on the bottom. 2/4 can be reduced to 1 over 2. And there's another 2/4. And then you've got some 2 over 2's. So there's a lot of canceling out of those 4's. In fact, all of these 2's and these 2 4's end up completely canceling each other out. And the only factors really that remain are 3 times 3 times 3 times 3 on the bottom, which is 81. So let me get out a little fraction bar here, and the number part is going to be 1 over, not 1/8, but 1 over 81. It's a typo. So there's the number part of our answer. Last thing then we have to do is to think about all the variables, and there are a lot of them. I'm going to think about them one variable at a time. And so if we look at just the u's, there are 12 u's on top, there are 8 u's on the bottom. And so when you're thinking about variables, in this case, now you're going to think about who wins and by how much, because some of these u's cancel each other out. There ends up being 4 u's left on top, and so you would have a u to the 4th in the top of your answer. Finally, when we look at the W's, there are 6 W's on top, and there are 16 and 12 W's on the bottom. And again, if we think about who wins and by how much, on the bottom, the property says that we can add these exponents. That would be 28 total. So 6 versus 28, there are 22 more u's on the bottom than on the top. And so here would be our final answer then. U to the 4th over 81 w to the 22nd. And that's the idea behind simplifying expressions with exponents. This is a beastly problem because it involved every single one of those steps, and that was on purpose. When you create yours for the final project, you should have many of these steps. I don't know if it has to be this bad, but definitely groups, probably a negative exponent at some point, and then the rest of it can go from there. All right. Another skill that we learned, this is a really important one, something that you'll be using throughout the rest of your math career, I'm sure, and that is simply taking an expression like this and factoring it by factoring out. And so to factor out, I suggest you think of that as the reverse distributive property. And your goal is to write it like this, with something pulled out in front and kind of what's left behind inside of the parentheses. Process I said to do was to start by finding the greatest common factor, and that is looking at the numbers and what's the biggest number they can all be divided by, and looking at the letters and what's the most amount of letter that they all have in common. And then write that on the outside, and then inside of the parentheses, write what's left. And that technically is what you get when you divide by the greatest common factor. And you can always check your work by multiplying it, doing the distributive property. So, if in this example, I've got 3 different terms, and so my goal is to write it as something, and then times 3 things that give me this. So that is the reverse distributive property. And first thing I'll do then is to look for the greatest common factor. What's the biggest number that 10 and 30 and 5 can all be divided by? And I think that's 5. And then what's the most amount of letter that they all have in common? They all have at least an A in common. They all have at least one B in common, but after that, they're a little bit different. And so the greatest common factor will be 5AB, and that's what I put in front here, 5AB. Then I have to look at what times 5AB gives me 10AB. And so 2, I need a 2. 2 times 5 gives me 10. I also need one more B. B times B would give me the B squared that's here. And so 2B is what I write in this blank. Here I need what times 5 gives me 30. That would be 6. And I already have an A, and I already have one of the B's, but I need C to the 4th. And so I need a 6 and a C to the 4th to make that happen. And then in this last blank, it kind of feels like I've pulled everything out already. 5 and A and B. I chose this example on purpose because it happens a lot. You can't leave this blank. You have to put something there. And specifically, you need to put a 1. Think about 1 times 5 gives me 5. And so there is our final answer. And if we wanted to check this, we could distribute. 5 times 2 is 10. AB times B is AB squared, and so forth. So that's the factoring out strategy. Be careful if you're going to write your own that when you choose your numbers, you'll want to make sure that they have a common factor. Alternatively, you could start with what you want the answer to be, multiply it out, and then oh, I forgot what the question was. And then you can do your work, and lo and behold, your final answer will be exactly what you wanted it to be. That's how I set up problems. All right, another really important skill that we learned this year was multiplying polynomials. And so here is a binomial times a trinomial, 2 terms times 3 terms. And there's kind of 2 schools of thought for how you multiply polynomials. I tried to teach you both of them. One is to simply use the distributive property. So you take 3x and multiply it by each of these, and 8 and multiply it by each of these. I like to summarize that with some arrows. So 3x times x squared, 3x times negative 4, and so forth. The other technique is to use a table. And I'm a big fan of the tables. I'm going to show you both techniques because I think it's important that you're flexible. But Anyway, if we have to use these distributive property ideas, then we have 6 different multiplications to make. And if we do that, 3x times x squared is 3, and x times x squared becomes x cubed. 3x times 4x is negative 12x squared, 3x times 3 is 9x, and so forth. So here are all the different multiplications you get when you multiply all 6 of those arrows together. And then you almost always have like terms that you can combine. And so if I look at these 6 terms, this is the only x cubed term in my answer. When I look at these, there are 2 x squared terms, and now you've got to think about who wins and by how much. There's more negative x squareds, 4 more of them, so negative 4x squared would be the next term in our answer. When we look at the x's, there's 9x's and negative 32x's. There's more negative than positive, and so that's negative 23. And then the number part is 24. It's the only number term in the problem. So here is our final answer. That's distributing, and it's probably the most popular technique. You'll see that in textbooks and so forth. Sometimes the acronym FOIL is used. That only works if you have 2 terms times 2 terms, but you might remember that. Anyway, how do I prefer to do problems like these? I like the table, and so to do the table, what you do, let me make some room a little bit, get rid of these arrows a moment. To make the table, what you do is you put the first term along the side, and so first factor, excuse me, so 3x and 8, and then the second factor along the top, negative 4x and 3, and then in each one of these boxes you do one of the multiplications, and so in this box I'll multiply 3x by x squared, and that gives me 3x cubed. And in this box, I'd multiply and get negative 12x squared. And in this box, that's 9x's. Down here, I get 8x squareds. And negative 32x's. And 3 times 8 is 24. And so here are the 6 multiplications. It's the same 6 that we had when we used the distributive property, but now they're kind of organized. You'll notice along the diagonals, like terms are gathered up. And so it comes a little bit easier maybe to sort it. 3x cubed is the only x cubed term in our answer. These x squareds, again, combine to give me negative 4x squared. These x's, again, the negative is bigger by 23. And this is the only number part in our answer, so 24 is in there. And that's the idea. I like the table because it's kind of organized, and students don't accidentally forget a term or something like that, or do a term twice when they do it in the table. So anyway, one last important skill that we learned, and that is to factor quadratics. And so here is 2 different expressions. This is one in called factored form. This is in standard form. When you go this way, that's multiplying. That's what we just did on that last slide. When we go this way, that's called factoring. And that's generally a lot harder to do and not always possible. In fact, in your exam project, when you are making up a problem to factor, you can't just pick 3 random numbers and have it be factorable. And so here you definitely want to start with one of these. Pick something. I chose my daughter's ages. So I have a 10-year-old, a 7-year-old, I have a 3-year-old, and I have a couple 1-year-old cats. And so those are the numbers that I included here. And I multiplied that all out. Here's 10 times 3, 30. 7 times 3 is 21. 10 times 1 is 10. 7 times 1 is 7. Gathered the like terms, and that gave me this. And now I'm going to pretend that I didn't know that. And my goal is going to be to factor this. How can I write this as 2 things times 2 things? That's how you ought to set up your problem, to multiply something out first, and then start here and work backwards. So the process I used to do this is a table. And I always suggest you work to fill the insides of the table first. And once you know the insides, the outsides are forced. There's no guesswork or anything like that. It's going to be something predictable. And so this is going to be where the 30x squared comes from. And this is going to be where the 7 comes from for sure. And then these two terms have to be x's, and they have to add up to 31. Also, in order to make it factorable, these two have to multiply to the same thing that this diagonal multiplies to. And so this diagonal, 30 times 7, is 210. So I need to come up with a combination of x's that multiply to 210 and add to 31. And this is what I call the puzzle within the puzzle. Every one of these always has one of these sorts of things. You've got to come up with a combination of numbers that multiplies up to and adds up to. And I would focus on the multiply up to, because even though that's a big number, there's not that many ways that you can multiply to give us 210. And so here is a list of all the different ways that you can multiply to 210. I didn't just know this. I had to do some grunt work by typing it into a calculator. I tried 210 divided by 1, 210 divided by 2, 210 divided by 3, and so on, and produced this list. And finally, I'm looking through this and looking for the combination that adds to 31. And that would be this combination down here, 10 and 21. And so what that means is in this corner, I'm going to write 10x. And in this corner, I'll write 21x. Honestly, if you flip-flop those, it doesn't matter. You just get your answers flip-flopped on the outsides here. And the final step is then, now that I have the insides, now figure out what the outsides are. Sometimes students get into trouble by trying to guess the outsides before they figure out the insides and they get stuck. Only now do I do that, and I do it by factoring out. I look at the top row and I say, what's the biggest number that they can both be divided by and the most amount of letter that they have in common? They both can be divided by 10. So I'll write 10 here, and they each have at least an x in common. And so I'll write 10x. Now this is forced. This has to be 3x to multiply. And down here, this is forced because 3 times 7 is 21x. And that forces this to be a 1. And so now my answer is the outsides. So final answer here is 10x plus 7 times 3x plus 1. And notice that was exactly what I said it was going to be. So anyhow, that's the idea behind factoring, and I hope you are able to use some of these skills towards your exam. And let me know if you have questions or if you have troubles coming up with any questions of your own, because I'd be glad to help. Just shoot me an email. Have a great one. I'll see you later on.